Okay, so the first lesson is going to be over significant figures or significant digits. Sig Figs or Sig Digs for short. I prefer Sig Figs in my class. The first thing we need to discuss is an estimated digit. An estimated digit is one place value further than your measuring device is capable of recording. So that would be something like a meter stick or triple beam balance, graduated cylinder, those type of things. So let's set this up and let's just go ahead and say this is a meter stick and that we're going to measure some object, maybe a block or something, and that the block comes out this far. Okay, so if we just extend this line down here, that's where the object needs to be measured to. So this meter stick is capable of going to the tenths place. Okay, each one of these markings is 1/10. Okay, so we know that our block is at least 0.2 centimeters long, but it's less than 0.3 centimeters long. So if we were going to write down its measurement, we would say that it is 0.2 something, and that something is our estimated digit. That's the thing that we have to come up with. We have to decide how far in between 0.2 and 0.3 is that block. Okay? Okay, so if I extend the area between 0.2 and 0.3, I zoom in on it, then we can see that our red arrow actually falls right here. So our estimated digit is going to be 5. Okay. So the measuring device itself, the meter stick, is capable of reading up to the tenths place, and my estimated digit is going to go in between the tenths place so that we move out into the hundredths place. And I estimate that that arrow is halfway between 0.2 and 0.3, which would put it at 0.25. So I would say that our block is 0.25 centimeters in length. Okay, so like I said, estimated digits, something that we're going to always use whenever we measure anything. Okay, so the next thing we're going to talk about are Sig Fig rules. Okay, this is how to decide how many significant figures a number has. And while we're on that subject, let's go ahead and define what a number is and what a digit is. Okay, this whole thing here is a number, and that number is comprised of individual digits. Okay, so the whole thing is a number, and the individual parts of that number are digits. Okay, so the first rule is that if there is a decimal in your number, so for example, let's say we've got, I don't know, 100, okay, that has a decimal in it. So if there's a decimal, you start on the left-hand side of your number, okay, and the way I remember that is that decimal has an L in it and left has an L in it. So you're going to start on the left-hand side of the number, and you're going to find the first non-zero digit. That means a digit that's not 0. So for us, that would be 1. You're going to count that number and everything after it, moving in the direction from left to right. So this number has 4 significant figures. Okay? Alright, so what if we had this number? Okay, let's apply the decimal rule. Does the number have a decimal? Yes. Find the first non-zero digit. We're going to start on the left-hand side of the number. Find the first non-zero digit. That would be 5. So how many significant figures does this number have? 1. Okay. Now let's come over here and look at the no decimal rule. Alright, if your number does not have a decimal, you're going to start on the right hand side of the number, find the first non-zero digit, count that one and everything after it, moving in the direction from right to left. So for us, the first non-zero digit is 1. So how many sig figs does this number have? 1. What about this number? Let's apply our sig fig rules. Is there a decimal or no decimal? Okay, no decimal. So we'll start on the right hand side of the number, find the first non-zero digit. That would be 4. And then count that one and everything after it. So the 2, the 1, and the 1. So how many significant figures does this number have? 4. Okay, so now we know how to decide how many significant figures a number has. And this is going to become very important later on whenever we do calculations and measurements, so that we can always maintain our accuracy level throughout all of our work. Alright, we'll leave it here for today. Thank you for learning with me, and I will see you next time.